My name is Adria Wheaton. I'm with Utah State University Center for Water Efficient Landscaping. And Candace Shively is my co-host. She's also with USU Extension. And we are all part of CWEL. And this month, we have Kelly Kopp, who is part of our group. We wanted to hurry and snag her before she left on sabbatical at the end of the month. So we appreciate her joining us today. And she's going to be talking about turfgrass science and industry and how they've cooperated for water conservation. So Kelly Kopp is a professor and extension specialist in Plant Soils and Climate Department here at Utah State University. And her research efforts focus on landscape water conservation and sustainable turf management. She serves on the board of directors at USU's Center for Water Efficient Landscaping and is also a board member and past president of the Utah Water Conservation Forum. From 2007 to 2016, she served as board of directors for the Alliance for Water Efficiency, and that's an international organization promoting all aspects of water efficiency. Her service with AWE gave her the opportunity to work directly with members of the EPA's WaterSense team, and she continues to work directly with many federal, state, and local agencies in pursuit of water use efficiency in the state of Utah, the Intermountain West, and beyond. So before I turn the time over to her, I'm just going to mention if you do have any questions, there's a Q&A box down there as well. You're welcome to throw those in and we'll field those questions to Kelly, and then feel free to use the chat as well as we go along. And then I will be putting in links to CEUs in the chat box too. So if you are trying to get some CEU, some continuing education units, you can go ahead and look in the links there. So with that, I will turn the time over to Dr. Kopp, and we appreciate having you.
Thanks, Adria, and thank you, Candace, as well for hosting. It's my pleasure to speak as part of this webinar series, which I've been really enjoying myself. As Adria mentioned, I'm going to be talking about turfgrass science and how those of us who work in turfgrass science have been cooperating with members of the turfgrass industry to answer the call for reduced water use, which is growing louder by the moment, especially here in the Western US. So before I start with a whole lot of data and information, I'd like to sort of introduce the topic by talking about the environmental benefits of turf, because I think that the environmental and functional benefits of grasses in our landscapes are things that often get overlooked, and sometimes even with the best efforts towards water conservation, these things aren't considered, and I think that that's unfortunate and sets us all back in some ways. So grasses have very many environmental benefits, including producing oxygen, as do other plants. They help recharge groundwater by keeping water in place and reducing runoff. They suppress dust. They filter groundwater. They prevent wind erosion of soil, and they actually help to clean our atmosphere. But of particular note at this time of year are the cooling properties of grasses. And these properties are so effective that temperatures over grass surfaces on sunny days like we're currently experiencing in Utah can be anywhere from 10 to 15 degrees cooler, sometimes more, than over concrete or asphalt. So if you were to consider that another way, in a block of 8 average homes, that would be the front lawns, that is, would have the cooling effect of 70 tons of air conditioning. So that cooling effect is something very, very significant, and it relates to water use, of course, as well. Now, this is information out of the EPA, and what you see here are temperature differences over different types of landscapes. So these range from rural landscapes to suburban, more urban downtown types of areas, park areas, rivers, and farmlands. And if you, without getting into too much detail here, if you look at the temperature, which is signified by the red line across the image, you'll notice that areas with more green cover and more landscaping tend to have lower temperatures than other areas. In particular, highly urbanized areas, downtown business district type areas. And so those can be as much as 10 or 12 degrees warmer than nearby rural areas. Now getting into a little bit of the data around turf grass benefits. In this case, this is a study that the information comes from the Lawn Institute, and it's just a comparison, a fairly simple comparison of surface temperatures over different areas. So for example, on the top line here, growing Bermuda grass, which is one of the turf grasses that are out there, turf temperatures, the surface temperatures can range from 75 to 88 degrees Fahrenheit. If you consider bare soil under the same conditions, those temperatures start to creep up a bit, ranging from 79 to 102 degrees Fahrenheit. Now, if that grass is dormant, so no longer green in color, the temperature increases somewhat from 81 to 126 degrees Fahrenheit. And then if you look at the temperature over synthetic turf, again, in the same location, those range from 84 all the way up to 158 degrees Fahrenheit. So the take-home message here is that actively growing grass has the lowest surface temperature of all of these different surfaces that are being considered. Now there's been some similar work done at Clemson University. That's where this information comes from. In the upper left here, air temperature at this location is 94 degrees. Water temperature also 94 degrees. Over the turf, temperature does increase up to 104. Bare sand up to 132. Asphalt up to 136. And then again, synthetic turf, that surface temperature is up to 165. So again, just demonstrating some of the benefits of turf grasses, in particular, cooling of temperatures in this case. But those aren't the only kinds of benefits that come from grasses and from green landscapes. There's actually been a fairly significant amount of work done on diseases and public health. And one of those projects, I've just pulled one for the purposes today, looks at the link between disease prevalence and green space. And there have been many other studies as well that find that when there is more green space around, which of course can include turf grass, there are lower disease prevalence, and there are also fewer anxiety disorders and depression. And disease clusters also tend to be lower when there's more green space in the environment. So there are health benefits, there are environmental benefits, and those should be considered as we start this conversation about water conservation in turf grass areas. Now, having said all of that and really focused on some of the benefits, what I am seeing in recent years is a trend in the water conservation world, and this is largely being driven by water providers, water utilities, water wholesalers. But in any case, there is a trend out there towards programs that pay for removal of turf grass in our landscapes. And there is a misconception with these programs as to what turf grasses are, what amount of water they actually require, and there is no recognition of the environmental benefits of these grasses. And so this is one program that exists in Southern California where they're offering $2 per square foot to remove turf. This is a separate program also in Southern California where they are offering $1.50 per square foot. And again, they focus on grass just as a large conglomerate group of plants. And there is very little recognition about the differences between turf grass species, and even within those species, the differences between turf grass varieties in terms of their water requirement. Now, to be fair to these folks, this is a drought map from the entire US, but obviously I'm going to be focusing on the western portion of the map here. And we do regularly experience very, very severe drought in this part of the country. And so to be fair to those water utilities and wholesalers, I think they're trying to do the best they can. However, I think they could benefit from some better information from turfgrass scientists and the turfgrass industry as far as what actual water requirements are, and then what benefits might be achieved with appropriate turfgrass management. So the bottom line here is that grasses can be very functional in drought situations, but underlined, as you see, that is when they are managed properly. And this is where water utilities, water agencies are trying to sort of get rid of the problem. As opposed to teaching people how to manage grasses properly, they're trying to simply remove them from the landscape entirely, which invites a whole host of other problems that we may or may not be able to get into here today. But selection of drought-tolerant grasses and cultivars is absolutely critical in light of periodic drought conditions. In the state of Utah, at least, we have an incredibly quickly increasing population, all needing water. And then also in light of an increasing temperature just globally. So we have to be cognizant of what we need in terms of water conservation. And I'm happy to say that the turfgrass industry and turfgrass science is really stepping up in that regard. So how do we address this problem? What is industry doing? That's what I'll be getting into a little bit more. Now, we know that there are relative drought tolerance differences among the grasses that are commonly used for home landscapes, parks, sports fields, institutional landscapes, etc. So in general, the warm season grasses tend to be more drought tolerant than the cool season grasses. And of those, Bermuda grass tends to be more drought tolerant than, say, for example, St. Augustine grass. If we move over to the cool season grasses, the most drought tolerant tend to be the wheat grasses, and the least drought tolerant tend to be the rye grasses. So we already know that there are these differences among the typically used species of turfgrass. But of course, the picture is much more nuanced than that, and I'll be getting into that here today. So we have this understanding, but we also have this challenge, that is, there are a lot of different grass seeds available in the industry. If you were to go into a typical box store, typical nursery, you'd be met with so many choices in terms of turfgrass seed that it's really tricky to decide what is going to be the best choice for me, particularly if I have certain needs. If I'm trying to save a lot of water, what's going to be the best thing? All of the seed that you see there, they tend to be mixes, so they're including perhaps one or more species. They may include several varieties as well. And so it becomes pretty confusing very quickly. And the industry took a look at that and decided a number of years ago to start cooperating with turfgrass scientists across the country to try to clear things up a bit, make it a bit easier for someone who's trying to do the right thing in choosing a lower water use grass. Now, having said that, here's another example of what some of the challenges are. So what you see there are a number of different plots of Kentucky bluegrass. And by the way, I'll take just a moment here to acknowledge colleagues at the University of Arkansas, Mike Richardson and Doug Karcher, who have shared a few of these slides with me. But the point of this slide is just to illustrate everything that you see in this image is Kentucky bluegrass. And it has been treated exactly in the same way. But you can also see that there are some of the grasses that are suffering quite a bit more than others. Some of them don't look to be suffering at all under drought stress. And so this is where the challenge is. How do we promote, identify those species and varieties that are going to look terrific under drought stress and get those out into the market? So that's one aspect of this challenge. So the turfgrass industry has worked with turfgrass scientists to do drought evaluations of different grasses and varieties. And the idea is generally to screen a wide range of species and varieties for their response to different types of drought stress, which I'll get into. And then to identify really superior drought-tolerant cultivars within each species so that those could then be promoted to the public, to water agencies, cities, etc. And then beyond that, more on the basic science side, investigate the mechanisms, the physiological mechanisms associated with drought tolerance of the superior cultivars. And then finally, on the industry side, this is, you know, once things have gone through the evaluation process, those superior cultivars can be branded by the industry so that they get out there and are utilized more often. Now, one of the drought tolerance programs, drought evaluation programs out there, and I'll get into a couple of them here today, that we participate in here at USU is the Turfgrass Water Conservation Alliance. And this alliance was actually formed in 2010 by 3 seed companies that you see there. And I think it's notable that these companies are direct competitors. But they took a look at what was happening in the industry, what was happening with water, concerns about water, and they decided that it was to their mutual benefit to collaborate on projects that were going to help them identify lower water use varieties and species. And so they got together with some turfgrass scientists and developed a science-based approach to water conservation. And this program qualifies turfgrasses that really demonstrate water savings potential over conventional varieties of the same species. And they rely on peer review of data, which is what we do in science all the time to make these qualifications. And then they go beyond that to educate, reach out to other industries, government, and end users so that these products can enter the marketplace and become more available over time. So I'm going to describe a little bit more about the qualification process for this particular program. 2 years minimum of data is needed just to justify entry into the program. That is before the actual trialing starts occurring out at different institutions across the country. Once those varieties enter into the trialing program, they are evaluated for a further 2-year period. Data is collected over that time, which I'll be showing you in a moment. And they can have either acute or chronic drought imposed, which I'll also be describing more in a moment. And then they go through a peer review process, just as we would with any scientific work, so that it can be published and utilized. In addition, only the top 2 to 5% in terms of performance, only the top 2 to 5% of the varieties identified actually make it through the entire process and end up being marketed. So it's quite a long process. It's quite a rigorous process. And the idea is to identify those varieties that maintain an acceptable level of quality, even under drought conditions. And then once those are identified, they have to comprise a minimum of 60% of any blends or mixtures that the seed companies might develop and promote. Now, in terms of the types of drought stress that are imposed, they are either chronic drought stress or acute drought stress. And with chronic drought stress, irrigation continues, but it is significantly reduced from what would typically be applied or required. They're watered weekly based on measured ET on the sites where they're evaluated. And then digital image analysis is used to quantify percent green cover of the variety, because that is what is really utilized to determine which ones perform the best. So with acute drought stress, irrigation is completely stopped, and then the plots are monitored, again with digital image analysis, over a period of time until the very best performer reaches 25% green cover. So as you can imagine, once the very best performer reaches 25% green cover, everything else is looking pretty poor. Now, once that happens, then the plots are irrigated again, and recovery is watched over time to see how those grasses recover. And I'll show you some examples of that data here going forward. Just to sort of give you an idea of what we're looking at with digital image analysis. You're looking at this image, I'm looking at this image. I suspect that if I were to take a poll of the group, we might all have different ideas as to which of these plots was the greenest. And so we take the human factor out of it with our evaluation, and we take digital images of our plots and then evaluate those with software to determine which are the best performers, which are truly the most green. And so with digital image analysis, essentially it's measuring leaf firing as a function of green cover. What you see there on the left is a variety of Kentucky bluegrass called mallard. The digital image analysis of that is 38% green cover. On the right, that's Geronimo, another variety of Kentucky bluegrass, and that image shows only 2% green cover. So these are in the same location, treated exactly the same, but you can see a very significant difference in terms of green cover after 50 days, so nearly 2 months without any irrigation. And that's really the gist of what we're trying to do, is see which ones perform the best under these drought conditions. So a little bit more information on the digital image analysis. What you see there is a light box, and it's really a light exclusion box. But what it does is it excludes light from beneath the box, and then on the top of the box here is a digital camera. We place it over our plots. There are lights underneath the camera that provide a standardized source and quantity of light, and then we take our images, bring those back to the lab, and use software to evaluate them. So as an example, here we have some grasses on the left, and to determine the percent green cover, we would look at the number of green pixels in the image and divide it by the total number of pixels. So the image on the right, you can see there has been run through our software. And then if we actually look at the green pixels and determine percent green cover for these two, the image actually has 41.3% green cover. So that's sort of the process that we use with the imagery to get data for the, whoops, went the wrong way, various programs. Now, TWCA has, I should say, test locations all the way across the US, and is in a couple of locations is in Canada as well. Here in the West, there are locations in Oregon, California. Here we are in Utah. There's some in Arizona, as well as Arkansas and the East as well. And I just bring that up. I'm trying to impress upon the group that they really are trying to evaluate these grasses under very, very different climatic conditions. And that's important because it means that the results are more broadly applicable. And of course, as you go further north into Canada, it makes it that much more applicable. And it's not just differences in terms of climate conditions and weather, but also elevation, soil conditions, etc. So the idea is to really cover a lot of ground and to make the results as broadly applicable as possible. So I just will go very quickly through a few slides to show the installation process of one of these projects. This was the first project that we did here at USU with the Turfgrass Water Conservation Alliance, and it was bluegrass study that wrapped up in 2017. So this particular project would have started in 2015, but we have the site prepared, as you can see there. And then we go through the process of outlining our plots and placing the seed out in envelopes, as you can see. And with the rakes, what's happening there is once the seed is spread, those are being raked in. And this is just a standard process that is completed by every university that is participating in the program. So we go through that process. It's fairly time consuming. Then the plots are covered to facilitate grow-in. There we are, all finished up and starting to irrigate. So I guess I should note here that during the establishment process, irrigation is not limited. So these are established under well-watered conditions. This is the spring following our seeding. You can see there are a couple of blank plots there, but that's simply because we didn't have an exactly even number of varieties that we were testing, and we tend to fill those in with other species just to keep things as even as possible. But you'll see there are a significant number of weeds, which is to be expected. We're not going to be treating with herbicides to control weeds while we're trying to grow in new turf. So once things get a little bit better established, we get that under control and can continue the work. Now, you'll see, let's see this gentleman here. He is standing on the established plots. So you can see weeds are much better under control. Everything is well established and looking good. What we're doing at this point is we're actually installing a cover over this rainout shelter. The studies that we perform here at USU are acute drought studies, which means we turn off the irrigation and then we monitor the plots over time to see how long it takes to get to that point of the best performer having 25% green cover. So we're in that process now. It's essentially a large piece of industrial grade plastic that we will run over the length of the entire shelter. It takes a fair number of us to get that accomplished. Relatively few injuries, I'm happy to report. But then once we get that secured, you can see here the image on the right. This is what things look like underneath that rainout shelter. Now, that's part of the protocol for TWCA, and of course we want to follow that protocol. But here in Utah, at least, we typically don't have much precipitation during the summer months anyway. So it's not too difficult to have an acute drought study here at our location. There things are all completed. And sometimes I get asked about the effect of that cover on radiant light underneath the shelter. And we do check that and measure that, but it's really a very minimal difference whether you're under the shelter or outside the shelter. But we do change those covers every year, mostly to deal with dust that settles on the cover, as well as abrasion that might help from blowing dust and things like that. So, but generally speaking, there's very little difference in terms of solar radiation either under or next to the rainout shelters. So I am going to show you just quickly some of the results from this study, which we completed in 2017. I don't want you to get too concerned about the various names of the varieties that we tested, but I do want to point out some of the important information here just quickly. So what you see here is the amount of moisture that's lost to evapotranspiration before the test varieties reach different levels of green cover. So the green is 75% green cover, the brown is 50% green cover, and the yellow is 25% green cover. So I just want to focus on the 75% green cover for now and point out the difference between the highest performers here, which were utilizing on average about 5.5 inches of cumulative evapotranspiration and staying at 75% green cover, as opposed to some of the lower performing varieties, which were closer to 3 inches. So a difference of roughly 2.5 inches of water application, which can be very, very significant when you're considering an overall landscape and the area that it might cover. Now this is the same data, but it's looking more at recovery. And this is even more striking in terms of how quickly these grasses recovered to, for example, 75% green cover. So in this case, it took these higher performers as few as 20, I'm going to guess 23 days to recover back to 75% green cover, as opposed to some of the poorer performers, which were taking as many as 50 days to recover. So there are differences among these varieties in terms of how quickly they lose cover, and there are also differences in terms of how quickly they regain that cover. And so this is the kind of information that the industry folks use to identify which varieties they want to take to the next level, which is actually producing seed for sale and branding into the industry. So that was the Kentucky bluegrass trial that we performed with TWCA. But we do have another ongoing trial, which you see pictured here, and this is a tall fescue trial that's been in place for 1 year at this point, so we're sort of midstream in terms of data collection. And similar situation where we're looking at acute drought stress, so we turn the water off and we prevent any rainfall, as you see there with a rainout shelter, similarly to before. And then we monitor these grasses over time with digital imagery. I will just point out quickly before I move on to a little bit of preliminary data here, there are a couple of orange flags you can see out there in the plots. And these are varieties that have already been through the process and have been identified as lower water using varieties. But they are also put into the study as controls or comparisons. Now we do have some preliminary data here. It's a little less striking, I guess I would say, or maybe I should put it this way. The differences are a little more subtle, perhaps, than they were with the bluegrass, but this is just 1 year of data, and so we will continue to monitor those over time. But otherwise, the information is exactly the same, where we're looking at levels of green cover and as well as recovery, which I'm not going to show you here today. So moving on to show you just some other areas where this kind of work is taking place. In Manhattan, Kansas, there is a movable rainout shelter. So it travels along these tracks. Anytime there is rainfall happening, that's an automatic thing that happens. It moves to cover the plots. Otherwise, it moves off and lets the sun hit the plots. This is another movable rainout shelter in San Antonio, Texas. And just point out the costs of these structures per square foot, which in this case from $50 to $60. So fairly spendy in terms of cost for some of these structures. Here is another one, also a movable rainout shelter in Arkansas, $63 per square foot. And so what's happened over time with these projects across the country is that essentially everyone is moving to these types of rainout shelters simply from a cost perspective. They're very easy to work with. It's easier for us to change the covers, and they are much less expensive than movable rainout shelters like I just showed you. So just a couple other studies I want to share information about. This one was performed in Oregon. Similarly to what we do here in Utah, it was an acute drought study. They monitored dry down for 80 days and followed that with an evaluation of the green up. And this is just another representation of data similar to what I showed you before. But the difference between the best performers, in this case mallard, and the not so good performers, in this case Geronimo, is fairly significant. So 75% green cover was maintained for a significantly longer period with mallard, for example, as compared to Geronimo. So this is the type of data that would be collected. This is similar to what I did show you from our work here. I won't get into it too much except to say that, again, it's looking at how long is that green cover able to be maintained once irrigation is ended. Another trial, just quickly, this one looked at bluegrass varieties as well as hybrid bluegrasses and tall fescues. Again, imposing acute drought, so stopping irrigation entirely. And this is in this particular study, this is a plot area outlined here. And I just wanted to show you this image because it illustrates, I think you can look at that even without digital image analysis and see that certain varieties are performing much better than others. And so that is the whole purpose of this research. For example, what you see here, solar green, which is a variety of hybrid bluegrass, not doing so well under the conditions of this study. A tall fescue variety, second millennium, doing quite well. Thermal bluegrass, another hybrid bluegrass, probably somewhere in the middle. And then Kentucky 31, which is another very old variety of tall fescue, also doing fairly well in this particular study. Now, when we do actually look at the digital image analysis for this project, the red arrows indicate the performance of the hybrid bluegrasses. So these are bluegrasses that were thought to show great promise. And you can see that they performed very, very differently depending on which variety you consider. And so that's very, very useful information when determining what to promote, what to grow in terms of seed, and what to market. So generally, with both of these studies, the take-home messages are that the drought tolerance is really widely variable. As a group, the hybrid bluegrasses in this case were no more drought tolerant than regular bluegrasses. So, you know, that might guide the industry in terms of directions to pursue. And another take-home here was that drought tolerance of some bluegrasses was as good as tall fescue, which goes directly against some conventional wisdom, but is very interesting to know. So another study, and this one is different than anything I've shown previously today in that it was a chronic drought study as opposed to an acute drought study. And so as a reminder, what this means is that irrigation was applied to these plots, but it was significantly less than what would be suggested by measured evapotranspiration. And so water was applied every time the plot went below 40% green cover in this case. And they were looking at bluegrass, tall fescue, and in this case, they were looking at ryegrass as well. So just a few things to show you here. So here's that variety of Kentucky bluegrass mallard that I showed you. And here is that variety of hybrid bluegrass called solar green that I showed you. And green cover, as you can see, was very different between the two and was maintained for a longer period of time with the mallard. The other thing of note, and I don't think you have to look too carefully to notice, that the mallard didn't require as much irrigation to maintain that 40% green cover as did the solar green hybrid bluegrass. Now, when you consider what this means in terms of water volume and the potential for water savings, which really is the bottom line here, the difference between the total volume required by mallard to maintain that 40% green cover and the total volume required by solar green to maintain that 40% green cover was about 53% of that total volume. So if you can have a variety of bluegrass out there that requires half the water of typical or traditionally used varieties, that's a big deal. And if you look at that over an entire growing season, the volume savings can be very, very significant. So what was determined with this study, sort of the take-homes, the grasses that were selected, they were able to persist under prolonged chronic drought. There were some outliers occasionally with the data, but they were pretty minimal. And so these results suggested that acute screening was also going to be effective for identifying drought-tolerant cultivars. So this was some of the work that initiated with TWCA and has since resulted in a number of different seed products, which you see listed here. These are the trade names that the particular industry folks, industry partners in this program have utilized to describe some of these products. But these all contain seed that have gone through the process that I have just described to you. And if you go to, well, I'm showing you them here, but also on the TWCA website, which is tgwca.org, you can find lists of approved varieties. And here what I'm showing you are tall fescue varieties and fine fescue varieties. But of course, there are also Kentucky bluegrass varieties that have been certified, as well as perennial ryegrass varieties. So they are really trying to cover a lot of ground in terms of the species that they are considering. So moving on to another drought tolerance evaluation program that we participate in here at USU. I'd like to spend a few minutes now talking about the Alliance for Low Input Sustainable Turf. And this is similar to TWCA in that it was started with a cooperation between the turfgrass industry and turfgrass science. It is somewhat different, though, from TWCA in that the focus is really on reduced inputs of all kinds, not just water, but nutrients, herbicides, pesticides, etc. And so the idea is to evaluate and identify low input turf that can be used in different parts of the country. The protocols seek to identify the best performers under reduced input and management. The original A-list members and cooperators included several seed companies that you see listed there, as well as several institutional cooperators, of which Utah State University is one, and several others that you see there as well. The protocols in this case, so again, somewhat different from TWCA, but there is fall establishment of the trials. If fungicide is required, it is only at establishment, and this is an issue typically in the locations that are further east. This is not something that we deal with here at Utah State. Herbicide may be applied at establishment only, not beyond. And then there are pretty strict requirements in terms of fertility as well. So again, the idea being that every type of input is reduced. In this case, very little nitrogen input, whether that be during establishment or an ongoing maintenance level. Phosphorus is allowed as per soil test. Mowing height is kept at 2.5 inches, depending on species or region. And then irrigation is withheld starting July 1st, and the combined effects of heat and drought are considered. Current A-list trials, we are participating in a Kentucky bluegrass trial here at USU. There are several other institutions also participating in that, as well as a tall fescue trial. Fine fescue is being trialed at Rutgers and Purdue University. And then perennial ryegrass is being trialed at a couple of the seed industry cooperators, as well as UC-Riverside, Rutgers, and Purdue. Now, one other difference I would say between this program and a few others is that they have identified control varieties. Well, every one of these programs has identified control varieties, but they are very specific about it with A-list. Kentucky bluegrass, you see 4 listed there. Tall fescue, you see 3. Fine fescue, and perennial ryegrass. And these are varieties that have been around for a period of time, are known to have certain performance characteristics, and therefore make great comparisons to some of the newer experimental varieties that are being tested. With A-list, temperature and evapotranspiration rates, that information is collected. Percent green cover and density as described by digital image analysis is also collected very similarly to the program I presented a moment ago. And turfgrass quality is also rated visually on a scale from 1 to 9. And then the frequency of data collection is also very carefully prescribed. So 1 or 2 times per week during dry down, the images are taken. Turf quality, visual quality that is, may be measured monthly or more often, depending on the individual researcher. And then density is also measured monthly after the turf is established. And then this particular program gives those of us on the research side a little bit of leeway in terms of any additional data we might like to collect. For example, something that I'm very interested in here at USU is what goes on with soil moisture with these different varieties. And so that's something that we might choose to monitor in addition. Now the A-list program does recognize the very great differences between the eastern and western United States. So as you'll see in the eastern US, water is withheld beginning July 1. When the last plot, meaning best performer, reaches 25% green cover, then irrigation is begun again to look at recovery. In the western US, depending on the species that's being tested, we might apply just 60% of ET starting in the 2nd year, and then stop that at 60 days growth in certain other species. So things are a bit different than they would be in the east, although the data that's collected is exactly the same. So with this particular program, varieties are approved similarly to TWCA. They have to demonstrate superior performance as demonstrated by percent green cover under the conditions of the studies. And they also have to have acceptable or better turf quality for each of the 2 years in at least 2 locations. So that is something that they make sure of to identify those species and varieties that are doing well in multiple locations. And then they also will have to be entered into a national turfgrass evaluation program trial for the species. And once that happens, then they can be finally approved as an A-list variety. So I just want to, we're still in the process with our A-list study, but I do want to just share a little bit of data from other locations that have been participating a bit longer than we have. So for example, UC-Riverside has taken a couple of different approaches to their A-list studies. In 2014, they did a study looking at 2 drought cycles that were imposed where they would stop irrigation and then let things decline to a certain point and start it again. And in that case, the amount of water that they applied during that, or lost, I should say, during that first cycle was 4 inches of ET. During the second drought cycle they imposed, they lost 3.5 inches of ET for a total of 7.5 inches. Now, when that's compared to a volume, that means that in the first case, 2,720 gallons could have been saved, and in the second case, 2,380 gallons, and that's per 1,000 square feet. So a significant amount of water savings could have been achieved with those varieties. Now their second study, which was in 2015, they looked at 6 weeks of irrigating at 60% of evapotranspiration. So over that period of time, 6 inches of water was applied, and there had been 10 inches of total ET. So 4 inches of water was saved, resulting in 2,720 gallons of water saved per 1,000 square feet. So just a graphical representation of what these studies look like. This was the first study in which 1 cycle of drought was imposed, and then a second cycle of drought was imposed, and then recovery was followed over time. And you can see there were quite a few varieties tested, and there was a pretty wide range in terms of performance there. Now, this is the second study in which case they were applying 60% of ET and then monitoring what happened over time and how quickly the different varieties lost percent green cover. And this is tall fescue in this case. So similarly to TWCA, A-List has approved a number of varieties as of this year. These are the varieties of tall fescue and fine fescue that have been approved as part of the program. They have also approved a number of perennial ryegrass varieties, as well as a couple of, 6 Kentucky bluegrass varieties. And we are actually participating now in another Kentucky bluegrass trial with them. So we'll see if the number of bluegrass varieties doesn't increase there. So I want to leave you with some take-home thoughts as far as using the information that these programs provide. I think the bottom line is that there are a number of improved turf grasses and species and varieties that are water savings alternatives to higher water use varieties. They are out there, they are commercially available, and they can result in a significant amount of water savings over some more traditionally used species and varieties. TWCA, there's the website you see there, has qualified a range of brands, species, and varieties, as has A-List. They've also qualified a range of species and varieties. And what's exciting to me right now, too, is that there are a number of other programs, including the National Turfgrass Evaluation Program, that are also starting to really focus on water and identifying varieties that do perform extremely well under reduced water application. And we are also participating in some partnerships with private industry, which I can't really get into here today, but just individual companies who want to pursue varieties that are going to use less water, and so they're working with universities like ours to identify those varieties. You know, there's always a question of unintended consequences, and where I'm talking about unintended consequences here, it has to do with unintended consequences as they relate to turfgrass removal programs, for example. When turf grasses are removed from our landscape, what is the cost in terms of lost ecosystem services? How much more air conditioning, for example, do we end up using because our structures are warmer, because we've removed that green cover? And there's something else that I always think about in water, and that is that water is embedded in energy. So oftentimes water is used to produce energy. And so if we're having to produce more energy for cooling, are we really saving water by taking it away from irrigating landscapes and putting it into generating energy? So just some things to think about. And some other things to think about in terms of some of the turf removal and, you know, new landscape type programs that I see promoted quite a bit in the water industry. And that is that anytime you have a new landscape, there are establishment levels of irrigation required. And so what that means is that encouraging folks to change landscapes during drought conditions means that they are going to be using even more water to get those landscapes established than they might for their existing landscape. And so the timing of some of these things is something that has to be considered. And again, also the unintended consequences that can result from some of these programs. So, I very much appreciate you participating in the program today. That is my contact information. I've listed a couple of different resources there. Of course, the CWEL website, which is the sponsor of this webinar, is a resource I would encourage you to check out. And I have also included a list of references here if you'd like to learn more about some of the data that I presented. But I'll leave it here on the contact slide for now and perhaps open it up to questions.
Okay, thank you, Kelly.
Sure.
If you do have questions, go ahead and put them in the Q&A. It looks like we have a few more minutes. So I've got a few questions for you, Kelly, that have come in.
Okay.
So I'll just throw those at you if that's all right. So Tyler asks, are any materials available regarding the benefits of turf grass that would aid in preventing anti-turf legislation or incentives that you know of?
Well, there's data in terms of, you know, there's a fair bit on that temperature moderation that I showed towards the beginning. So I believe I have some of those listed in the references. In terms of reduced water use, you know, we also have that data. We know that certain varieties can use less than half what others were required to maintain green cover. So again, in the references, there are some of those. I think if you're looking for something quick and relatively easy that, you know, sometimes with legislators, and maybe Adria would agree with me, sometimes with legislators, they're looking for a fairly simple explanation, and that's okay. I mean, when you've got to cover so many things, I can understand that. And so I think that some of the information out of the Lawn Institute, which is an organization that also sponsors research, is also fairly helpful in that regard. So the lawninstitute.org is another organization I would direct you to. They've actually developed a couple of different informational pieces that I think could be very helpful for that.
Okay, thank you. The next question we have is from Matthew. Do these disease studies and health studies specifically outline turf as being more beneficial than other green space such as trees, cacti, shrubs?
So more the public health part of it? Yeah. The one that I presented does not specifically call out turf, no.
Okay. And then the next question we have is, how were the research plots irrigated?
How were the, okay, it depends on which project. Would they like to maybe be a little more specific?
Yeah, William, if you want to add a little more info on that, I'll just go to the next question, if you had one specifically in mind. Thomas asked, what ecosystem services are you referring to with turf?
Okay, so there is atmospheric cooling, there is carbon sequestration, there is prevention of soil erosion, there is increased organic matter content underneath turfgrass surfaces, there is reduced, let's see, reflected heat. What else could I add to that? I guess I would just add to that in terms of carbon sequestration, there's been some work done to show that grasses actually sequester more carbon than any other plant material in our landscape. So as far as I'm concerned, that's a really, really important one.
Okay, thank you. Next one is, what effort is given to encourage turf growers to grow low water use grass species?
Okay, so I didn't mention it in the presentation, but I can tell you that there are a number of sod growers in the country who are starting to look at programs like TWCA, A-List, and now more also the National Turfgrass Evaluation Program. And they're choosing varieties for their growing operations from those that have been qualified or approved. And so there are more and more of those growers who are recognizing the benefit to their business by choosing these lower water use varieties. So my position here, just to expand on that a little bit, my position here at USU, I am the Extension Water Conservation and Turfgrass Specialist. So what that means is that I have opportunity to interact with and work with growers in the state, and it's something that I definitely promote to them. Now, you can't just flip a switch and have new varieties in a sod growing operation, and so it's a pretty significant change that some of them are looking to make. But between folks like myself across the country, the turfgrass industry, so the folks that are sponsoring this kind of research, as well as some of the more open-minded progressive water utilities, they are promoting these to growers so that we have more sources for sod for these products.
Okay, a couple more questions, a little clarification on that last one. So the plots underneath the rainout shelter, were they irrigated by hand or sprinklers?
Oh, okay. So in our case at USU, under the rainout shelters, we do have sprinkler irrigation there, but when we're running a study, we don't utilize it. I think I did show another study where it may have been under a rainout shelter, and it was a chronic drought study, and so in that case they were still applying irrigation, but it was at a much lower amount than ET would recommend.
Okay.
I hope that helps.
I think that's the question. If not, ask me again. We'll try to get it right here.
Okay.
So another question from Lisa, in the Western U.S., is the turf market still saturated with cool season varieties? Are you seeing any shift in market supply to more drought tolerant varieties? Any leading vendors in the West?
Well, first I would say that there are drought tolerant cool season varieties, so I'm not particularly concerned with that, except if we're trying to grow, I wouldn't want to grow cool season grasses in Arizona, for example. So it's very location dependent, but there are some very low water use cool season grass varieties. I'm seeing a shift even here in Utah in that direction. I'm seeing some increased use of warm season grasses, especially in the southern part of the state. And again, it's very location dependent, but I am seeing that shift. Just as a bit of an aside, one challenge that we've had here in Utah is that Bermuda grass is still on the state's noxious weed list. And that's really unfortunate because hybrid Bermuda grasses are very, very low water use. And so, some of those things are institutional challenges that we have to overcome.
Okay, Thomas has a question. How does soil quality under turf, including soil organic matter, compare to soil quality under low water use plants? Is it completely dependent on inputs? And then another part of that question is it possible to get that source on sequestering carbon? Do you have a link to that, or should they just email you directly?
Why don't you email me that directly?
Okay.
I have the book over here on the shelf. I'd have to get it out.
Okay.
But the other question, as far as, let me think back. It was organic matter under turf as opposed to
under low water use plants.
Low water use plants.
Yeah.
Okay. A lot of what goes on with organic matter under any plant material has to do with the root mass and volume. And that's where grasses tend to be really strong performers. There's a lot of root mass and volume underneath the ground, and as that turns over, it increases the organic matter content. And in addition, as you know, just a basic management practice, what I always encourage homeowners, turf managers to do is to return grass clippings whenever possible, because they decompose and provide additional organic matter. And so it's just it's a nice recycling of not only organic matter, but nutrients as well into that soil. I have to say that I am not an expert on what goes on in the soil underneath low water use plants. But again, I think the same principles would hold, that if it's got a nice, healthy root volume and mass that is active and turning over, then it's going to also have improved organic matter content. The big difference would be that they tend to cover a less area of the landscape as a whole, because when you've got turf grasses, you're typically covering a larger area. Where you've got low water use plants, they're not typically covering the entire area. You might have one here, one there, and so it's simply a matter of covering ground, which I hope that helps.
Sounds good to me. Okay, looks like we're good on questions, and we are out of time as well. So this webinar is being recorded and will be available up on the CWEL.usu.edu website in the next couple of days. And if you have further questions, feel free to email Kelly at kelly.cope@usu.edu. And our next webinar will be in August. We're in August already. So it's the second Tuesday at 2 o'clock, and we hope to have you join us then. And once again, thanks to Kelly Kopp and Larry Lipke, who was hosting this webinar today. Thank you.
Thanks, everybody.